Hello everyone. Now let us see the third group of the oxidation of olefins to the diols. So up till now we have seen a group of reagents showing oxidation of benzylic and allylic hydrogen in a molecule. We have also seen a group of reagent which will oxidize the olefins to epoxide, and now we are going to see the oxidation of olefins to diols. So here these are some of the reagents. Now here on this slide we are going to study two reagents in a comparative way, because both in Prevost hydroxylation and in Woodward hydroxylation, these both are silver based oxidation. There is a minute difference in the reaction condition. So let us see one by one. In both the reactions the substrate is alkene, and in Prevost reaction we use iodine and the silver salt of benzoic acid. While in case of Woodward, the iodine is same, but the silver salt of acetate or silver acetate we will use in wet or in presence of water molecule. So here the condition of the reaction in Prevost hydroxylation is dry, and here the condition in Woodward hydroxylation involves the water molecule. The product of the reaction in both the cases is vicinal diol, but in Prevost hydroxylation you have anti-stereochemistry of the diol, and in Woodward hydroxylation it is cis diol. So let us see the reaction and the mechanism. So in case of Prevost hydroxylation, an alkene when treated with the silver salt of benzoic acid, 2 equivalent and 1 equivalent of iodine, it will give you this diester, which on basic hydrolysis gave an anti-diol. While in case of Woodward reaction, when an alkene is treated with the iodine using this silver salt in presence of water, it will gives ester on one side and hydroxyl group on the vicinal carbon, and which on again basic hydrolysis gives diol. But this stereochemistry of the diol is cis. Now let us go through the mechanism of the reaction. In Prevost hydroxylation, in the first step, there is a silver salt of benzoic acid reacts with the iodine to give AgI, and this salt, which will I plus adds on this double bond and gives you this intermediate, which is iodinium ion, and then the benzoic acid which will attack from one side, and this 3-membered ring will open up. So here then the lone pair on oxygen will attack from the back side and it will displace the iodine. So we'll get a cyclic 5-membered ring structure with the positive charge on the oxygen. So again we are having this nucleophilic O- benzoic acid which will attack on the carbon where the positive charge on the oxygen. So that bond will shift to the oxygen, and then there is a formation of this diester. Now this particular molecule when we will carry out basic hydrolysis, it will give you diol. So you can see that as this molecule, acid molecule, it is attacking from the back side to the carbon, the stereochemistry of this bond and the bond which is formed due to this attack, it is on the opposite side. So that's why the stereochemistry is anti. Now come to the Woodward hydroxylation. We will be having this silver acetate and then iodine which will give you AgI. This salt which is formed, then iodine will attack on the double bond, will give this intermediate, which is then attacked by this acetate ion, and it will open up this ring, 3-membered ring. We'll get this molecule, and now again in this case the oxygen, it will displace this iodine and will get this molecule. Now there is a positive charge on this carbon which is attacked by the water molecule which is present in the molecule. So this water molecule will attack, and there is an opening of this ring. Now the water molecule is attacking on the carbon and not on the carbons which are attached to the oxygen in the diol. So that is why these two oxygens are present on the same side, and there is an opening of this 5-membered ring takes place by the attack of this water molecule, and after hydrolysis of this ester will get in diol. Now here the stereochemistry of the 2 hydroxyl compound is cis. Now what are the features of this, general features of this reaction? Both acyclic and the cyclic alkenes are the good substrate for these reactions. This reaction will be takes place on the isolated double bonds, and as we have discussed earlier that the dry reaction condition is needed for the Prevost hydroxylation and wet reaction condition is needed for the Woodward hydroxylation. Here there are some of the examples where this molecule is there. Now iodine is given, the silver salt of benzoic acid is given, and water is not there. That's why it's a dry, it is also already mentioned that it's a dry reaction condition. So we have to find out the double bond here, alkene. So this is the double bond, and we will get an anti-hydroxylation. Again we can see this is, we will see this is the double bond, and then the reaction condition involves iodine, but here the reaction condition involves water also. So it's a wet reaction condition, and that's why the diol which is formed is syn.